Hey guys, this is going to be a video in response to a few questions I've been having, and basically a few videos flying around YouTube on people asking what voltage shall they be running their machines at, rotary machines. Now, first of all, if there was a magic number to run a rotary machine at, a magic voltage, the cat would be out of the bag by now, and everyone would know what the voltage is to run these machines. And the reason there's so many varied answers is because there isn't a single answer to it. There's not a definitive, well, it runs at this amount of volts, I could say to someone, hey, if you've got a Dragonfly, line with it at X amount of volts, shade with it at Y amount of volts, and colour pack with it at Z amount of volts. And you go away, you plug your power pack in, and you'd run it at that amount of volts, and it might work for you, it might not. And if you're watching this video and you've searched this video, and you want to know how many volts you should be running a rotary machine at, well, the question shouldn't be what volts should you be running the rotary machine at. The question should be asking is why. Why are you running the rotary machine at however many volts you're running it at? And now, I'm a firm believer in knowledge is power, and if you've got the knowledge and you know why you're running a rotary machine at the volts that you're running it at, then it's going to put you in a lot better stead. You're going to be able to make decisions on the fly. You're going to be able to change voltages and why you're changing them, and not just because someone on YouTube's told you to run a certain machine at X amount of voltage. So let me explain why we choose the volts we choose to run any particular rotary machine. This video, this is a Dragonfly X2 from Inks Machines, but after you've watched this video, hopefully you'll have the knowledge to go away and pick up any rotary machine, top-end rotary machine, Stigma Prodigy, Spectra Halo, anything like that, and you should be able to make an informed decision on your own and go say, hey, I know what voltage to run this at. So, before we get into what the correct voltage is and why we choose the voltage, we need to go to coil machines, because rotary machines have basically been made to mimic coil machines, to mimic the speed, mimic the motion. And the reason why we need to go back to coil machines, the reason why these are important, is because coil machines, we know what speed these are running at when we plug them into a digital power supply. Now, first of all, let me start by saying, if you're watching this video, you've never used a coil machine, you're scared of coil machines, my mentor told me, because I was gung-ho, when I first started tattooing, I just wanted to use a rotary machine, plug and play, let's go. My mentor said to me, hey, he's been in the business 30 plus years, old school guy, and he said, look, whether you're going to use coil machines or not, you're going to learn them. You're going to learn coil machines. Whether you want to use them for a career or not, you're going to learn coil machines. He says you're going to learn how to strip them down, you're going to learn how to put them together, you're going to learn how to tune them, you're going to learn everything about them. That was the best piece of advice I've ever had, tattoo-wise. The best piece of advice. And I'd recommend anyone, if you're first getting into tattooing, don't pick up a rotary machine to start with. That's my advice. Do the legwork. You owe it to the art anyway. Get a coil machine. Get a decent coil machine. This is Mickey Sharp's Hornet Mark IV. Get a decent coil machine. Learn it, because what you learn from a coil machine will directly impact how you use a rotary machine. You can't gain the knowledge from a rotary machine that you can from a coil machine. Why are we talking? So, if I were to compare these two, let's say these two are two cars, okay? And a rotary machine is an automatic car. You can get in it. There's no gear stick or stick shift, or whatever you want to call it. You get in it, you press the gas, and you go. You want to stop, you press the brake. It's plug and play. You plug it in, you go. There's no tuning involved. coil machine would be a manual car. You've got stick shift, a gear stick, you've got gears, you've got the clutch down, you put it in gear, and there's a bit more about it, a coil machine. And I get why people are, they don't really want to learn them when they first get into tattooing, because they just want to jump on the Rotary. But my point being is, if you look at these as two cars, if you learn to drive an automatic, and you don't know how to drive a manual, and you've never drove one, you just drive an automatic, you can't get out of an automatic and jump into a manual, because you won't know how to drive it. Whereas if you learn a manual with the stick shift, you can drive this, and you can jump out of this and jump straight into an automatic. And that's like a similar analogy to how it works with tattoo machines. If you learn a coil machine, learn everything about it, you can jump onto rotaries no problem, but you can't jump from rotaries to coil machines. Okay, so why am I talking about coils? Why is coil machine so important? Because we're trying to mimic the speed of a coil machine. Now, if you plug a coil machine into a digital power pack, you'll get the CPS, the cycles per second. One cycle is the armature bar going from its utmost point down to the bottom and coming back up. If it did that in 1 second, it'd be running at 1 cycle per second. If it went up and down 10 times a second, it'd be 10 cycles a second, and so on. So, if we plug, and we get this information on the screen on a digital power supply. Now, if we plug a rotary machine into a digital power supply, we don't get this information. So we haven't got a clue how many cycles per second a rotary machine is doing. So first of all, we need to know what we should be running a coil machine at, and then we can work out how to get the cycles per second for a rotary machine. So a coil machine, there's some ballpark figures that they should be running at, which most people in the tattoo industry would agree with. And these are ballpark figures, okay? So I know there's extremities, you're going to get people saying, hey, I tattoo with a way faster speed than that. You get people say, I tattoo slower than that. But I'm on about average ballpark figures. So a ballpark figure for a coil machine to line at will be anywhere in the region of, we're talking cycles per second, so to line a coil machine, you're looking anywhere in the region of around about 110 cycles per second to 130 cycles per second. Again, this is the needle going up and down 130 times a second to about 110 times a second. That's what we'd line at. Now, to colour at, it'd be a lot slower than that. So to pack the colour in, because you're just chilling with your machine, you do a nice slow circles, you don't want it to be running balls out because you're just going to tear the skin up. So to colour, you're going to be looking at around about 80 to 100 cycles per second, so which is a lot slower. And for shading, you'd be anywhere in between lining and colouring really, so maybe from 90 cycles per second to about 110 cycles per second for shading. Again, the ballpark figures. So if anyone says, well, I go a lot faster, I go a lot slower than that, well, again, it's an average. It's a thereabout figure. And these speeds are really, really important. If you've ever seen videos, which I'm sure you've seen the pros on YouTube tattooing, and they're just chilling with the machine, and let's say they're packing some colour in on a new school piece, and you see them there and they're just chilling, and then they wipe the skin off, and the ink's in, it's beautiful, it's packed in solid, there's no blood, it's not raised up, and the guy might as well be using a marker pen. There's a lot of reasons for that. There's technique is a big reason for that, ink, equipment, machine, and all the rest of it, but a big reason for that is he's got the right cycles per second, the machine's running at the right speed. Now, some people, they say, hey, right, I've seen this guy on YouTube, he's got this machine, he's got this needle, he's got this ink, I'm gonna copy this guy, and he goes away home and tattoos. I'm not condoning tattooing in your kitchen, I know people do it, and I'm not going to start a debate about it, end of the day, I'm just giving this video on what the correct voltage is to use. But he goes away and he starts tattooing his friend, and he puts the needle in, he's got the same machine, he's using all the same things as this guy, he's the same guy on YouTube, and he starts to go at this guy, it's looking good, the ink's pooling around the area and it's looking good, it looks like it's packing in, it's like, hey, this is working. And then he wipes off the excess ink and shit. Okay, no ink's gone into the skin. The skin started bleeding straight away. It's gone buff and buffed up, you know, like 30 seconds later the skin's raised up like a mountain, you know. And then he says, right, I'm going to pack some more until you go over it again. And all you're doing is you're just tearing up the skin. And no amount of time, you know, every time that machine goes over that same area, it's going to be detrimental to what you're doing. That piece of skin is damaged. It ain't going to take any more ink. And what's going to happen is it's going to eventually going to heal. It's going to heal patchy or no ink in it at all, and you're going to end up with a scar. And the reason for that could be a lot of reasons, but one of the main reasons is that this guy, he's got one of these rotary machines, he's plugged it in, he ain't got a clue what speed this is running at, and this machine could be running balls out at 140 cycles per second, and he's just taking nice slow circles and it's running 140 times a second when it should be running about 80 or 90. So that's a reason why that can be happening. So we know our ballpark figures now with a coil machine. So how do we now transfer, you know, if we plug a rotary machine in to a power pack and it doesn't tell us these cycles per second, how do we work it out? I'm going to tell you. With any top-end rotary machine, when they come from the manufacturer or from the tattoo supplier, they will come with either like a manual with the specifics of the motor, or it will be on the manufacturer's website. Now this is a Dragonfly X2, and on the website, on Ink Machine's website, there is a specification for the motor. And if you look under the specifications, it will say on this particular machine, it will give you the maximum voltage that you can run the machine at. So on this machine it says 13 volts, and then it says 8,000 revolutions per minute, which is saying if you run this machine at 13 volts, it will go up and down 8,000 times a minute, the motor, the needle, sorry. And also, you know, a lot of good manufacturers, they'll give you, they call them the stitch count, the stitches per second. Stitch per second is basically, well, it's exactly the same as a cycle per second. They call it stitches. Maybe they call it stitches because, you know, it's like a sewing machine, maybe they call them stitches. But if it says stitch count is the cycles per second. And on this particular one, it's wrote on the Ink Machine's website, the cycles per second is 130. Cycles, that's 130 cycles per second when it's running at the maximum voltage of 13 volts. So with this information, we can work out now exactly what volts we need to run at to get those ballpark figures. So if we know that this machine runs, when it's running at 13 volts, the needle's going up and down 130 times a second, we divide 130 by 13. Now that's going to give us cycles per second per volt. Are you still with me? So we've divided 130 cycles per second by 13 volts, and that works out at 10 cycles per second. So this particular motor will run at 10 cycles per second per volt. So we'll run at 1 volt, it'll go up and down 10 cycles per second. We'll run at 2 volts, it will go 20 cycles per second, 3 volts, 30, 4 volts, 40, and so on, up to 13. So now we've been able to work out our cycles per second for this particular machine. We can say, right, okay, so I colour pack at 90 cycles per second. So I check my chart and I say, right, so this machine, it achieves 90 cycles per second when it's running at 9 volts. So I run it at 9 volts and I can colour away with this machine. I'm matching the same speed as the coil machine. Okay, I want a line, so I want a line at, let's say, I want a line at 110 cycles per second. Again, check my chart. Where's 110 cycles per second? Okay, 11 volts. So I'm going to run this machine at 11 volts to line with. If I want to shade, again, I want to shade at, let's say, 100 cycles per second. Again, check my chart. 100 cycles per second is 10 volts. So now I know exactly how many volts I need to run this machine. Now, working it out like this, you know, don't go away and, you know, say you've got a Spectra Halo or something. I've never used one, but I don't know, the motors might be different in them. So when you run a Spectra Halo at 10 volts, it might be getting more cycles per second or less. So you need to go to their website and check it out and see what that particular machine runs at. So, you know, if you've got a Dragonfly, then you can use the chart that I've just come up with, because this is based on this particular motor. But all tattoo machines have slightly different motors, you know. When you, like again, I'm using the analogy of a car, you know, all cars aren't made with the same engine. You get like some sports car where you just tap the gas pedal, you know, just slightly volts, just a few volts, and it's going to go really fast. And you get other cars which are really sluggish, and you put, you know, just tap the gas pedal again, and it's going to go really slow. So it's the same thing with the motors. You have to find out the specifics of that motor for the machine that you're using. Okay, so the last thing I'm going to say about this is, you know, everything that I've just told you and everything we've just discussed, this applies to the original motors. You know, if you buy a Dragonfly or any knockoff from eBay and it's a clone, it's not gonna, that we've all discussed isn't gonna apply, because if you look on Ink Machine's website, you know that they've invested a lot of money, and the information up there is going to be exact for this particular motor. If you buy a knockoff off eBay, it's going to come with a cheap Chinese motor, and it's not going to run the same revolutions per minute. So, like we discussed, say I'm going to run this at 9 volts to colour with, and you buy a clone and you run it at 9 volts, it might be running balls out at 160 cycles per second. Quite literally, you know, tearing the skin up. So my advice would be, guys, buy original. If you're in it to win it, you know, and you're involved with tattooing and you're serious about it, get the right tools for the job. So that's it, guys. I hope this has been helpful for a few people, and if you like this video, don't forget to hit the like button, subscribe to my channel, and there'll be more videos coming up soon. Thanks, guys.